Hello, Algebra 2 students. This is Mr. Bear bringing you Skill 11. Today we're going to talk about exponential growth and decay. So we're going to build upon what we talked about last class. I promised you all that we would be talking about how we can use the exponential models to help us solve real life problems, and we really want to focus our energies on your financial futures, as this is probably the most relevant application of exponential models. All right, so we're going to start with how we figure out any exponential model. So when you are dealing with things that are growing by a certain percentage, we're going to use a balance formula that looks like this. Y equals A times 1 plus R to the power of T. So R is going to be your growth rate. Notice it'll need to be as a decimal. T is going to be time. That'll need to be based on whatever you are, whatever the units are in the problem, but most likely going to be years. And then A is your initial balance, so starting value. We talked about that last time, as the A is like your y-intercept. This equation looks a little bit different than what we talked about yesterday, because yesterday we were just generally talking about a B value raised to an exponent. Your 1 plus R is going to be your B value that we talked about. And the reason why we have 1 plus R is because we're going to either increase or decrease our rate by a certain percentage. And that'll make more sense when we do some problems. But for now, let's go ahead and talk about some situations. All right, so congratulations. You recently started a new job. Your company offers you a retirement plan, which includes a 401k. That's just the legal name for the retirement plan. It's what companies typically offer. And in this 401k, you are guaranteed a growth rate of 6% annually. Okay. To qualify, you must first deposit $26,000 into your retirement account by the end of the year. Assuming you do not put any more money into the retirement account, how much will you have saved when you retire in 40 years? All right, so to help us do this, we're going to look at a little chart. All right, so we're starting with $26,000. The interest that is going to be earned, what you're going to do is you would take that $26,000 and you would multiply it by your 0.06. And then what would happen is you'd ultimately add that on to the balance. So if we think about this, 26,000 multiplied by 0.06, that's going to just tell us what the interest is, okay? So I'm going to take 26,000 and I'm going to multiply that by 0.06. We would earn an interest of $1,560. Okay, that's the interest earned, but we're going to add this value on top of the 26,000 that we started with. That's why when you look at the B value here, or the rate here, we are doing 1 plus the rate. So what we really want to do is multiply by 1.06 to figure out our new balance. So what I would do is I'd take 26,000 and I multiply it by 1.06. And we're just doing that one time. So what I'm going to do is I'm going to recalculate that, and I get 27,560. Okay. So that's going to be our balance that we're going to put in the next line. And then we're going to follow this process. We're going to take the 27,560 and multiply it by 1.06. And we get 29,213 and 60 cents. Okay. So we're going to carry that balance over to year 3. And we just take that value and multiply it. Oops, I forgot the 0.60. we're going to multiply that by 1.06 because we're going to multiply by the 6% and then add it to the 100% of the balance we had before. And we're going to get a balance of $30,966.42 when rounded. Okay? All right, so that's kind of where this is going, but this would get tedious if I did it year after year after year. So let's cut to the chase. What if I work that career? Let's say you start at 25 and you retire at 65. That's 40 years. So how do I figure this out if I didn't want to have to calculate year after year? Well, you would just use that formula, y equals a times 1 plus r to the t power. Your a is your initial investment, which is 26,000. You have your 1 plus 0.06 raised to the 40th power. So then what we do is we just work this out. We already knew that 1 plus 0.06 is 1.06. And so if we did this for 40 years, I'm just going to put this in on my calculator. I take 1.06 to the exponent of 40. And then whatever the calculator gives me, multiply by 26,000. And ooh, look at this. $267,428.67. Bazinga. All right, so the equation for t years, well, essentially, I just take that general form that I had, the a times 1 plus r to the t, and just substitute in the a value, which is the initial value. And then my 1 plus 0.06 would be 1.06 to the t. And you can use that equation to help you figure out any number of years. Okay, now I have to stress this while I'm thinking about it. I'm going to get on a soapbox for a second. This amount, this $267,000 or whatever, that is assuming you don't add money to your 401k. You should add money to your 401k each year so that number continues to grow. Furthermore, if you get down the road and you find yourself in a financial hardship, please, please, please don't borrow from this 401k. If you do that, you will lose a lot of that compounding power, which is what's happening here. You are compounding your interest each year. And when you reduce that balance, the percentage isn't going to be as high. And therefore, it's going to cause you to not compound as much. And it's harder to make it up because, especially if you pull it out after 20 years, you've lost all that compounding power. So please, 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 if you've not learned anything from this course this year or this lesson today, don't pull from your 401k. Don't do it. Just don't do it. Okay? Don't do it. All right. I'm off my soapbox now. Let's try another one. Oh, and this situation happens. All right, so your old company that you were working for when you started this process went out of business. You're forced to find a new job. Unfortunately, this new company does not allow you to roll over your 401k savings from your past job. It's odd, but it happens. You will have a fresh start. This company will give you compounds twice a year. It will also guarantee you the same 6% growth annually if you deposit $26,000 to start. So what would this look like? Okay, so this should say 26,000 because you're starting there. It's a typo. I'll make sure to fix that. Okay. So the interest earned in the first half of the year. So what we're going to do is we're going to take that 6%. That's your annual. So what you would do is you take 0.06 and divide it by 2, which would be 0.03. So we're going to take 26,000 and we're going to multiply that by 1.03. And so what we're going to do, let's go ahead and figure that out. That gives you 26,780. And I'm running low on room here. sorry, I'm cutting right to the chase on these. So the balance would be $26,780. And then what we're going to do is we're going to take that 26,780 and we're going to multiply that by 1.03, which gives us $27,583.40. Okay, so I'm kind of doing this a little bit differently than the chart shows here. So what we're going to do is that number that we came up with here, that is actually going to be our balance at the end of year one. Okay, so 27,583 and 40 cents. And what we're going to do is we're going to take that amount and we're going to multiply it by 1.03 for the first half and 1.03 for the second half. Okay. You know what? I've written the models. I don't feel like rewriting all these, so I'm just going to take that 27,583.40 and I'm going to multiply it by 1.03. That's going to give me $28,410.90. So what I'm going to do is I'm going to take that number and I'm going to multiply that by 1.03, which gives me a value of $29,263.23. That's going to be my balance after year two. So then we carry that number down here, and if you're going to be an accountant one day, this will be your life, just dealing with numbers and spreadsheets. I'm not saying it's a bad thing, but it's definitely something that you would use an Excel sheet for, because this gets tedious the way I'm doing this here. All right, so I'm going to take that value, the $29,263.23, multiply it by 1.03. Now I have $30,141 and 13 cents. So I'm going to take that times 1.03 and we get $31,045 and 36 cents. So that's what's happened after 3 years. I want to compare that number to what we did after the first 3 years here. It was $30,966. So it looks like we're coming out a little bit ahead. Not a whole lot ahead, but a little more than what we originally thought. So if I subtract that $30,966, we've got an extra $79. But how would this work after 40 years? Well, to figure this out, I'm going to use a modified equation. We're going to have A times 1 plus, we took our R and we divided it by the number of times a year that we compounded. So if we look here, we compounded twice a year. So I would divide that generally by 2, or specifically by 2, but generally by n. But the number of times that I multiplied by 1.03, it's no longer just one time, but it's n times the number of times that I did that. So this is actually the equation. I'm actually doing this for here. And then what I'll do is I'll plug in my 40 and my 2 and my 26,000. So we're going to have 26,000 multiplied by 1 plus 0.06 divided by 2 to the 2 times 40 power. So let's clean this up a little bit. We already knew that 1 plus 0.06 divided by 2 gave us 1.03. There will be a total of 80 times that we compound. So I'm going to take 1.03, raise it to the 80th power. My calculator will give me something. And then I'm going to multiply that by 26,000. And that's going to give me $276,663.15. Okay, so that actually answers the 40-year question. Okay, so when we look at that, compare that to what we had up here, it was 267,000. Now it's 276,000. So we're looking at almost a $10,000 jump just by compounding twice a year. What would happen if we did this 3 times a year? So my n would now become 3, so I'd have, it would look like this. And I'm just going to do all this on a calculator. I'm going to assume at this point you know how to do this. And then we would multiply that by the 26,000. This gives you a really big, oh wait, no, it wouldn't be what I had. Sorry, 0.06 divided by 3 is going to give you 1.02. So we do 26,000 times 1.02 to the 1/20th. I figured I should write that because I made a mistake when I did this on my calculator. I forgot to change the 1.03 to 1.02. All right, so 1.02 to the power of 120, multiply that by 26,000, and we're going to get 279,894 and 24 cents. So if we did this 3 times a year instead of 2 times a year, you would get an extra little over $3,000, it looks like. Not bad for not doing anything extra. So then if we generalize this, it's going to be, I've already stolen the thunder here. It's just going to be that formula I wrote at the beginning of this little section. But this is the formula that you would use, and that's how you would deal with compound interest. Okay? All right, last thing here we want to talk about with exponential models is how to deal with when a car depreciates in value. So a little less financial, although it is still financial, but let's say you want to sell a car one day. You're not going to sell it for what you paid for it. You just aren't going to do that. So you buy a new car and you show on average the new car depreciates by about 9.9% per year for the first 5 years. So you bought the car for $36,000. How much will it depreciate after 5 years? So what's going to happen here, since we're decreasing, we're going to write our equation, instead of 1 plus r, we're going to do 1 minus r. And the reason for that is because we're decreasing in the value. So generally, we're going to do y equals, we're going to take our 36,000, and we're going to do 1 minus. Now 9.9%, if you take that 9.9 and make that into a percentage, you have to move that decimal 2 places to the left, insert your 0, so 0.099, which will give us y equals 36,000 times, if we take 1 minus 0.099, that gives us 0.901. And because this value is less than 1, this 0.901, we know it's going to decay in value. So if I take 36,000 and multiply it by 0.901, we're going to get that the new car after 1 year is $32,436. And if we do that after a second year, what we would do is we'd take that 32,436 and multiply it by 0.901, and we'd get 29,224.84. And then we would multiply that by 0.901, so after 3 years, the car is only worth $26,331.58. If we do this after t years, it would be worth a times 0.901 to the t, which I guess would be 26,000. I should put that in the front. And we could use that to figure out how many years it would take. So what's the value after 5 years? Well, I would just do 26,000 times 0.901 to the 5th power. Use your calculator to figure that out and then multiply. Looks like it would be worth $15,438.22. Okay. All right, so that is how we work with exponential models. So we will practice some examples in class, and you will have an opportunity to do some problems in your Delta Math. All right.